Okay, so now we're going to talk about functions and their graph. So our first objective is to graph the function. So number one, we're going to complete the table and graph this function, f of x equals the absolute value of 2x minus 4. So we're given our x's, so we're going to just put our input our -2 in for our x, okay? And then we'll write our output, which is our y, in for our f of x here, and then we'll write it as an ordered pair, which is the ordered pair is what we'll plot over here at the end, okay? Alright, so to start off with, we're going to have the absolute value of 2 in parentheses, since we're putting -2 in for x, -2 minus 4. So that's going to give us, well, 2 times the -2 is a -4 minus 4 gives us the absolute value of -8. The really cool thing about absolute value bars is they always give us a positive output, so the absolute value of a -8 is going to be 8. Okay, so our f of x then is going to equal 8, and our ordered pair is going to be -2 because that was our x, and 8 was our y, or our f of x. Okay. So for our -1, we're going to have the absolute value of 2 times -1 minus 4. That's going to give us the absolute value of -6, which again is going to be a positive 6. Ordered pair -1, 6. Now we're going to plug in 0. So 2 times 0 minus 4 gives the absolute value of -4, which is 4. Now we have 1 absolute value of 2 times 1 minus 4. Oh, that's absolute value, not a parenthesis, sorry. So that's going to equal absolute value of -2, which equals 2. So again, we're going to have absolute value of 2 times 2 minus 4, absolute value of 0, which this is just 0. Absolute value of 2 times 3 minus 4 gives us the absolute value of 2, which equals 2. So we have 3, 2. We're out of colors. How about red? Absolute value of 2 times 4 minus 4. It's going to give us the absolute value of 4, which is 4. Okay. So now we're just going to plot these points. And let's do orange, I guess, for our baseline. I'm going to make it a little bit down here, I think, for our it's our x. That's terrible. Y and x. Okay, so let's just plot our points. So if we, I'm just going to start at the bottom and go up, I guess. So we could go over 4 and do 4 and 4. So 1, 2, 3, 4. 3 and 2. 2 and 0. 1 and 2. 1 and 2. 0 and 4. -1 and 6. 1, 2, 3. And -2 and 8. And then now we can just connect our dots or our points. There we go. on a little bit. I missed that kind of a little bit. Sorry for that. Okay. So that would be our graph. Alright. Here we're going to obtain information from the graph of the function. So we're looking to find our domain, our range, our x-intercepts, and our y-intercepts, okay? So remember, domain is how wide it is, right, from left to right. So we can see that on the left, it goes off forever into negative infinity, and this one goes to positive infinity. So our domain, always denoted with the capital D, is from negative infinity to positive infinity. Our range is from the bottom to the top, right? How tall? So our range begins at -2. And it's a filled in dot, so it touches that, and it goes to infinity, which we can never reach, so that's a parenthesis. Now, x-intercepts are where it crosses our x-axis, right? So it crosses our x-axis at -2, 0, right here, and +2 and 0. So and what about the y-intercept? That is where it crosses the y-axis. So where does that happen? That happens at 0, -2. See that? Because your x is 0 and your y is -2. Okay, now let's consider the function f of x equals -5/2 x plus 8. And we want to see is the point 4, -2 on the graph of the function. Well, to see if this is true, if it is, we're going to plug the points 4 and -2 into this function, and if it gives us a true statement, then it is on the graph. If it gives us a false statement, it is not. So we're going to say -2, because 2 is our y, equals -5/2 times 4 plus 8. Now we can simplify, say -2 equals -20 over 2 plus 8. Alright, now let's start our cancelizations. Well, 2 goes into -20, -10 times. So let's go this way again. -2 equals -10 plus 8. I can simplify further by saying -2 equals -2. That is a true statement, so we know that the point 4, -2 is on the graph of the function. So that is a yes. Okay, now for B, it says if x equals 6, what is f of x? What point is on the graph of the function? So we're just going to take 6 and plug in for each of our x's. Okay, so that is going to give us f of 6 is going to equal -5/2 times 6 plus 8. So if you see it right off the bat, you can go ahead and take 2 and divide it into 6, right? So 2 goes into 2 one time and 6 3 times. So -5 times 3 is going to give us -15 plus 8. That's going to equal -7. So this is going to be -7 is what our y is going to equal. In our ordered pair, we plugged in 6 for our x, and -7 was our output. Okay, if you didn't see that just straight off, you could say -5 times 6, which would have given you, 30, and then divided by the 2, and that would have given you 15. It would have been the same. That's what's so awesome about math, right? Okay, let's do C now. So if f of x, that is if y equals 3, then what is our x? So this time we're going to solve for x. Okay, so we're going to say 3. Now that is going to equal -5/2 x plus 8. So to find out what x is, we've got to solve for just x. So we always move the man who stands alone. So let's subtract 8 from both sides. I'm going to have to move him up here. We're out of space. So 3 minus 8 is going to give us a -5. that is going to equal a negative 5 halves x. Let me kind of move that. Okay, so now to get x by himself, we do this really cool trick and we multiply by the reciprocal. So this side I'm going to multiply by a negative, 2/5 reciprocal, right? And then this side I'm going to multiply by a negative 2/5. Now, the negative 5 and the negative 5 will cancel here. That's going to leave us, let me go this way, with 2, and this negative 2, and that will cancel. That's going to leave us, with 2 equals x, sorry. So our x equals 2 here. So our ordered pair is going to be 2, 3. Okay. Let's move to the next one. It says the zeros of a function are also the x-intercepts, right? Because that's where it crosses the x-axis of the graph of the function. To find the zeros of a function, we set the function equal to 0 and solve for x. Right on. So here we're going to find the zeros of the function f. This is our f, whose graph is shown below. So it's just your x, your zeros are your x-intercepts. We just said that, and that's where it crosses our x-axis. Here's our x-axis right here. So what would they be? Well, they would be negative 2, 0, and 2, 0. Okay. For this one, I gave you guys in your shell a list of basic functions. So this is where you're going to use it to help you with this problem, okay? So it says list 6 basic functions. It's not a table. It's in that thing that I gave you to describe each graph, okay? So we have the constant, which is just a line, right? Where y equals a number. That's your constant function. I'm not going to write function after each one of them, but please know they're each a function. There's also the identity function, right? That's where your y equals your x. We also have the quadratic. Cubed. Square root. Cube root, and then absolute value. Okay. Alright, now you guys are, I'm going to leave you with the do the math part, okay? Alright, well, have a great day.